Welcome to my channel Simple Concepts by DJ. Today we are going to see a circuit diagram. In this we are going to find the value of individual currents by a different method called as um, mesh analysis. This is called as mesh analysis by matrix form. By matrix form. This is a separate and a different method where we are going to apply this method, that is mesh analysis by matrix form. We are going to solve individual values using matrix, and we are going to get the individual currents that is flowing through this entire network. Okay, so we have different types of methods for finding the current. Okay, there is no specific thing like we need to find the current only by this method or by different. We have nodal analysis method, we have loop current method, we have this mesh analysis method. So many methods are there, so there is no specific direction that we need, directive that we need to find current only through this method. In case in your examination, if the examiner is very much concerned about one particular method, then you need to find the value of current using that particular method. If they ask generally, if they give telling that find the current in a circuit, means you can use any one of the method. You can use this mesh analysis method, or you can use the loop current method, or you can use the nodal analysis method, any method. Okay, so now here the examiner is very much concerned and he is telling that you need to find the value of current that is looping around the circuit, especially by using this method called as mesh analysis. We need to find this by using mesh analysis method. So let's get started. Let's see like how we need to construct this mesh analysis method. So the first thing is the format of this mesh analysis will be here I am constructing a matrix. Here this is R11, this is R12, R13. Similarly, this row will be R21, R22, R23, and here the final row will be R31, R32, and R33. Okay, this is matrix number 1. This is matrix 1. Now the second matrix is nothing but a column of individual currents I1, I2, I3. Right, this is a 3 by 3 matrix, and this is 3 cross 1 matrix. Okay, so this 3 cross 1 matrix is a matrix which indicates the individual currents I1, I2, I3. This will be equated to another matrix which is a 3 by 1 matrix, 3 into 1 matrix, which comprises of the voltages E1, E2, and E3. So this is the this is also a 3 by 3 into 1 matrix. Okay, so this is the general form of the mesh analysis. Okay, that is mesh analysis by matrix form. This is the general formula. Based on this, we need to work out various values for each and every parameters that is within the matrix symbol, and we need to work out and find out the value of individual currents that is looping around this circuit. So now first thing is we need to find the value of R1. See, we have 3 different compartments, that is compartment 1, compartment 2, and compartment 3. So when I using this R1, I'm going to find the value of R1 here, R11. R11 is in this compartment how many resistors I have. All the resistors which is intended to compartment 1 will be calculated over here. So I have one resistor of value 6 ohm and another value is 3 ohm resistor here. So this 6 ohm and 3 ohm contribute to the first compartment. Okay, so first compartment is contributed by this one. So 6, 7, 8, 9. So R11 will be 6, 7, 8, 9. So it will be 9 ohms. Why ohms? Because the unit of resistance is ohms. So I am putting 9 ohms. Next one is R12. So R12 means R12 means 1 R1 and 2 resistors in compartment 1 and compartment 2. So here this is compartment 1, this is compartment 2. So the resistors in compartment 1 and 2. What are the resistors that is very common in 1 and 2 means only resistor, that is the 3 ohm resistor. Okay. So this is the resistor, the 3 ohm resistor we are having. Okay. So this is R12. R12, 1 and 2, a resistor which is common for both compartment 1 and compartment 2. So R12 which is equal to R21. See, we have R12 here, we also have R21 here. So R12 and R21 both are, when we interchange the compartment, when 1 and 2, if 3 is common, similarly for compartment 2 and 1, 3 will be common. So R12 is equal to R21, that is a resistor value for compartment 1 and 2 will be equal to resistor value with compartment 2 and 1. So which is the common value is 3 ohm. That is, instead of putting 3, you need to put a minus sign and say minus 3 ohms. Okay, you need to add a negative sign. Similarly, R12, R21 we have found. What is R13? R13. So we need to find a common resistor which is connecting both compartment 1 and compartment 3. So here compartment 1 and compartment 3. Here compartment 1 is here, compartment 3 is here. In between you have compartment 2. So there is no physical connection between compartment 1 and compartment 3. So R13 will be 0. Okay, so R12 is minus 3. Similarly, R21 is also minus 3 ohms. Is minus 3 ohms. Then what about R22? R22 corresponds to compartment number 2. So what are the resistors? What are the resistors that are contributing to compartment number 2? So we have 3 different resistor values which is contributing to compartment 2. That is 3 ohm, 2 ohm and 4 ohm. 4, 5, 6, 7, 8, 9. So totally we have 9 ohms in compartment number 2. And next one is compartment 2 and 3. Resistor value for compartment 2 and 3. So for compartment 2 and 3. So R of 2, 3 equal to 2, 3, as well as I can interchange the compartment. Resistor value for compartment 2 and 3. Similarly, resistor value for compartment 3 and 2. So R of 3 and 2. Both will have the same value, but they have a negative sign attached in front. R32. So R23 common resistor value is 4 ohms. So it will be minus 4 ohms. Here it will be minus 4 ohms. Similarly for R3 and 1, this is compartment number 3 and this is compartment number 1. Compartment 3 and compartment 1 doesn't have any kind of physical contact. So R31 will be 0. Just like R13. R13 is equal to 0. Similarly R31 is equal to 0. R31 is equal to 0. So how about R33? R33 is nothing but the compartment 3. What are the resistors that is contributing to compartment 3? So we have two different type of resistors. One is 4 ohm and another one is 4 ohm that is being attached to compartment number 3. So why can't we add both the resistors? When we add both the resistors, R33 will be nothing but 8 ohms. R33 is 8 ohms. So we have found the values. So we have found the values for all the individual parameters, resistor parameters which is being fitted into this first matrix. We have found the values. Okay. So now we are left out with this matrix I1, I2, I3, which is the thing that we need to find. Then how about this E1, E2 and E3? So finding for E1, if I want to find E1, I'm going to apply the voltage law over here. If I apply a voltage law, what will happen means in this first compartment E1, let us assume that E1 is 6 volts. So if my direction of travel is in this direction, in the clockwise direction, So while moving in the clockwise direction, I happen to encounter a battery of negative terminal. That is, first is negative terminal, then is positive, then only it is positive terminal. So it will be plus 6. So it will be plus 6 volts. Similarly, when I get into E2, okay, so the value of E2 will be, my direction of travel is in this clockwise direction, and I encounter a negative terminal first, negative terminal of the 5 volt battery initially. So it will be plus 5 volt, plus 5V. Then E3, battery is E3. I am traveling in this direction. When I encounter a battery of positive terminal first, so I am moving from positive terminal to negative terminal. So I need to attach a negative sign, minus 10 volt, to my E3 value. So these are the values. These are the values that I had found. So from these values, I need to find the value of the respective current. Okay. So now for that, I'm going to put these things in matrix form. So if I put this in matrix form, it will be like this. Let us substitute in this one. R11 is 9 ohm. R11 is 9 ohms. Is 9. R12 is minus 3. R12 is minus 3. R13 is 0. R13 is 0. R21 is minus 3. R21 is minus 3. R22 is 9 ohms. R22 is 9. R23 is minus 4. R23 is minus 4. Similarly, R31 is 0. R31 is 0. R32 is minus 4. R32 is minus 4. And R33 is 8 ohms. R33 will be 8 ohms. So I1, I2, I3. So I'm minus 9, minus 3, 0, minus 3, 9, minus 4, 0, minus 4, 8. So I am erasing this. Okay, so now what is the value of E1, E2, E3? I'll substitute over here. E1 is plus 6 volts. So it will be 6 over here. E2 is 5. So it will be plus 5. And E3 is minus 10. E3 is minus 10. So these are the values. Okay, 6, 5, minus 10. So using this value, I need to find the mesh, and I'm going to do the mesh analysis using the matrix form. So first thing what I'm going to do is I'm going to find the value of delta. So the value of delta equal to modulus 9 minus 3 0 minus 3 9 minus 4 0 minus 4 8. So upon simplification, I will be getting 9 into 8 nines are 72. 8 nines are 72, minus minus plus, plus into minus equal to minus 4 fours are 16, minus into minus plus 3 into 8 twos are 16, 8 threes are 24, minus 24 plus 0. So which is equal to 9 into 72 minus 16. So 72 minus 16 equal to 56. 72 minus 16 is 56 plus 3 into minus 24, which is nothing but 56 into 9. 56 into 9 equal to 504. 504 minus 24 into 3. 24 into 3, which is 72. 24 threes are 72. 72. 504 minus 72 equal to 432, which is equal to 432. So the value of delta which we had obtained is 432. That is delta equal to 432. So now we need to find the value of delta 1. So delta 1. So delta 1 is nothing but delta 1 is equal to modulus of, we are going to substitute this value in the first column. So it will be 6, 5, minus 10, followed by this numbers minus 3, 9, minus 4, and followed by this number 0, minus 4, the camera minus 4, 8. So let's solve this one, which is equal to delta 1 equal to 6 into 8 nines are 72, minus into minus plus, plus into minus equals minus 4 fours are 16. So minus into minus plus 3 into 5 eights are 40, minus into minus plus, plus into minus equal to minus 4 tens are 40, which is equal to 6 into 72 minus 16. 72 minus 16 is 56. 56, and this term will get cancelled, nullified. So 56 into 6, 56 into 6 equal to 336. 336, that is the value of delta. 56 into 6 is 336, that is the value of delta 1. So now we need to find the value of delta 2. So finding the value of delta 2 equal to, we need to replace the column 2 with these numbers. So 9 minus 3 0, 9 minus 3 0, and this value 6 5 minus 10, 6 5 minus 10, followed by 0 minus 4 8, 0 minus 4 8. Okay, so the value will be delta 2 equal to 9 into 5 is 40, minus into minus plus, plus into minus equal to minus 40, minus 6 into 8 3s are 24, minus 24, 0 plus 0 and 0, that will be, so this value will be minus 6 into minus 24. So 24 into 6, 24 into 6 equal to 144, which is equal to 144. Therefore delta 2 equal to 144. We have found the value of delta 2. The final thing is we need to find the value of delta 3. So delta 3 is nothing but delta 3 is equal to modulus of 9 minus 3 0, 9 minus 3 0, here minus 3, 9, minus 4, 9 minus 3 0, minus 3 9 minus 4, and 6 5 minus 10, 6 5 minus 10. Okay, so upon simplification, delta 3 equal to 9 into 9 tens are 90, 9 tens are 90, minus 90, minus into minus plus 5 fours are 20. So minus into minus plus 3 of 3 tens are 30, 30, and this one will become 0, plus 0, followed by plus 6 into 3 fours are 12, plus 0. So this one will be 9 into minus 90 plus 20 will be minus 70, plus 3 into 30. 3 into 30 is nothing but 90, plus 6 into 12. 12 into 6 are 72. So that will be 72. So delta 3 value will be 70 into 9. 70 into 9 equal to 630. 70 into, this is minus 630 plus 90 plus 72. So minus 6, so 90 plus 72, 90 plus 72 minus 630 equal to minus 468, which is equal to minus 468. So this is the value of delta 3. Delta 3 value is minus 468. So we have found the individual values of delta 1, delta 2 and delta 3, and also we have the value of delta. Okay, delta. So what is I1? See, I1 is nothing but I1 value is delta 1 divided by delta. So which is nothing but delta 1 value is 336. 336 divided by delta value is 432. 432, which is equal to 336 divided by 432. 432, which is 0.77 amperes. 0.77 ampere. Similarly, the value of I2 is delta 2 divided by delta. Delta 2 value is 144. 144 divided by 432, which is equal to 144 divided by 432. 0.33 ampere. 0.33 ampere. And I3 equal to delta 3 divided by delta. So delta 3 value is minus 468 divided by 432, which works out to 468 divided by 432. So that will be 1.08, which takes the negative value minus 1.08 amperes. So using the mesh analysis, using the matrix form in mesh analysis process, we have found the values of the current I1, I2, I3. So these are the values of the respective current that are looping around the circuit through the mesh analysis network process. Okay, so this is the end of the solution. Thank you all for watching this video. I hope this video will be very interesting and informative to you. Please do subscribe. Thank you all.